polygons. Closed shape with the same number of sides and angles, basically. And so we have two categories of polygons. We have, convex versus concave. And just think of concave, it caves in, right? So you have part of that going in. To be honest, you won't really see concave. We won't really talk about concave. We will mainly stick with convex. And we have another category would be regular polygon versus irregular polygon. And how do you distinguish between regular and irregular? For a polygon to be considered regular, we need all sides to be congruent, and we need all angles to be congruent. Okay. All sides and all angles need to be congruent. And for irregular, I say that some sides may be congruent, some angles may be congruent. So the difference here is that for regular, it's all, right? So think of regular, you wanna make sure everything, like all sides are exactly the same in length and all the angles have the exact same measurement. Okay. So here are your examples, right? So for a triangle to be regular, all three sides will be the same. And we know that in this case, an equilateral triangle has all three angles the same as well. They're in fact 60, right? Because it's just 180 split in 3. So it is 60 all around. Okay. If you look at a square, all four sides are the same. We know that all four angles would be 90, right? So you have all four angles the same, all four sides the same. What about irregular? This would be an isosceles. An isosceles triangle, right? Like there's two sides that are the same, but not all. So it's not a regular polygon. So triangles, think of an umbrella. Polygon is like the umbrella term for all the shapes that you can think of, right? Triangles, rectangles, pentagon, hexagons, all of those are considered polygons. So yes, triangles fall under polygons, squares and rectangles also. So here you have a rectangle. What happened there? That's rectangle in French. No, I'm just kidding. I put like a rectangle. You will notice that all four angles are 90 still. So that is, right? All angles are congruent. Check. But not all sides are, right? All sides are not congruent. Therefore, it's not a regular polygon. So you can, but where you see versus, it's literally, this is the regular camp, this is the irregular camp, okay? So all the shapes you see on the right side would fail for various reasons. Maybe both are not, maybe all angles are different, all sides are the same, it doesn't matter. For you to be in the regular camp, all angles have to be the same, all sides have to be the same. If that's not meeting the requirements, you're on the other side, right? Let's keep going. All polygons have interior and exterior angles. Interior and exterior angles are supplementary. They have a sum of 180 degrees. And I want to use this shape right here. So Interior angles would be all of these ones inside that shape. I will put a capital I there. I like to use a color of some sort. Okay, so how many sides does this have? Let's count. I always count with a check mark. 1, 2, 3, 4, 5. Right? So it has 5 sides. I'll put that here. 5 sides, comma, 5 interior angles. And it will have 5 exterior angles. Where are the exterior angles? This is where they are found. Every single interior angle has its exterior angle as well. So watch this. If you go to this corner down here, you pick one of the sides. I will pick this side and you just keep traveling out and make it dashed, okay? So if you were to go out, extend this one base, the angle that is formed between that dashed line and the side of the polygon itself, that's called the exterior angle right there. And now I'm going to travel around the shape. So let's say you go along this line, you would extend it here. You extend this side, so that's E right here. Then keep traveling this way and extend that line. This is E. And we just do that all around the shape. 5 interior angles, 5 exterior angles. So notice the sides tell you how many interior angles, and it also tells you how many exterior angles there are. Can you tell, would you be able to tell me that this is true anyways just by looking at the diagram? That the interior and the exterior they add up to 180? I hope so. Is it pink day today? There's something weird pink, so we're going to do that. Okay. There's your supplementary, right? Interior angle plus the exterior angle always add up to 180 degrees. Straight angle is equal to 180. That's basically why we come up with that. Okay. And I think that is worth highlighting here if you want, and here one more time if you want. I'm saying the same thing twice there. And I'll just tell you the biggest mistake I will ask you sometimes on a test or quiz, identify the exterior angle on the shape. So let's say we just have a parallelogram and students find the interior angle. I might just ask you to identify one interior angle, no problem. And what about the exterior? This is the classic. This is the exterior right there, Mr. Dirksen. You like that? Because it's outside the shape, right? You should extend one of the sides. So if you go, so this is wrong. If you go down here and do it again, right, you pick one of the sides. So let's say you want to pick this side, right? That is correct. So it has to be in line with one of the sides, okay? So this is a common error. Okay. Anyways, another very cool property. Watch what it says here. Sum of exterior angles is always equal to 360 degrees. So, well, what are you saying with that, Mr. Dirksen? This could be a 500-sided polygon. And there would be 500 interior angles, 500 exterior angles. If you were to add up the exterior angles, right, the 500 of them, they would always add up to 360. So it doesn't matter if you have 4, if you have 3, if you have It doesn't matter how many exterior angles, they will always add up to 180. So guys, I'm just going to say one more thing. This property is going to be huge because if you know the interior angle, you can automatically calculate the exterior angle right that way. Because if this is 80, then you know this is 100. If this is 50, you know this is 130, right? So keep that in mind. Regardless of regular or irregular, regardless of the number of sides, right? So this is always going to be true. Let's keep going. Here are some formulas that I think, unless you're really good at memorizing, but I would just not even risk it, because if you get even one thing wrong, the whole thing is wrong. And think of months from now, you're going to need this for the exam or whatever. So these formulas should definitely be, this is on page 33, they should be on your study sheet. And so it's S of number of sides. So if you want the sum, right, sum of all the interior angles, you would use this formula, sum, and then you would insert the number of sides. So let's say it's a 4-sided, right? You go 4 minus 2 times 180. That's how you would find the sum of all the interior angles. If you just want the measure of one, right? So each interior angle, you would use this formula right here. Okay. And notice that there's an overlap. Look at this. The sum of all the interior angles is basically pasted here, and you're just now dividing it by the number of sides, essentially. And that's how you get each interior angle, right? The measure of each interior angle. So measure of each, or just one, okay? The central angle, I will show you where all of these are located in a bit. If they ask you the measure of each central angle, then you use this formula. If you want the measure of each exterior angle, right? Measure of each exterior angle, you would use this one. They're exactly the same, by the way. And you will probably see why later on. You will see how that's connected. And what's this one? D. Calculates the number of diagonals. Number of diagonals that can be drawn. I'm going to use pink for this part. Notice that ice, right, these three here, I, C, they only work with a regular polygon. Okay. They only work with regular polygons. Everything else works for all, right? So maybe I will add that. Works with regular and irregular. This one works with regular and irregular. And what are diagonals? What is that all about? Just hang in there. I'll tell you all about it. So let's put these to the test, and I will also identify where they are located. So it says label the interior, the central, and the exterior. Then calculate, I just use that for calculate all of these, right? SICED for the following regular polygons. So we're told every one of these polygons is regular for now, because that's going to change. We're going to do irregular, regular, but for now we're going to stick with that. So let's find one interior angle anywhere. So I'm going to go down here and say that that is I. That right there would be one interior angle. And the exterior would be just extending one of the sides, and so that angle formed is the exterior. And what's the C, the central angle? The central angle, watch this, you basically make a dot right down in the center of this shape. And then, I'm going to use a ruler, you don't have to, you go to one vertex or one intersection like that, and you go to the next one right next to it. That would be one central angle right here. It's like a pizza slice. Okay. So this angle that results, right, is what we call C. That's our central angle. Okay. So let's calculate these. 5 sides, right? Check 1, 2, 3, 4, 5. That means that n is equal to 5. Okay. That's what that is. Let's just do arrow, right? 5 sides, then arrow, saying that therefore n is equal to 5. So for all of our formulas, we're just going to use 5. Substitute that in. So the sum of a 5-sided polygon would be 5 minus 2. It says n minus 2 times 180 degrees. So let's figure out what that is. 5 minus 2 is 3. You go 3 times 180, and that is 540 degrees. So the sum of all the interior angles, and there are 5 of them, would add up to 540 degrees. Let's do the next one in that order. Interior angle of a 5-sided shape, it's still n minus 2 times 180 over, now you have to divide it by n, which is 5. The top, guys, the top here is the same as the sum, right? So you're basically saying take the sum and divide it by the number of angles. So I'm just going to borrow my answer from up here. I'm going to say 540 divided by 5. Right? And so I, of a 5-sided shape, the interior angle of each interior angle will measure 540 divided by 5, which is 108 degrees. Okay, so here you have I. Should I box this? I'll box this in like that. This is S. This is I. And central angle of a 5-sided shape. It says 360 divided by n, right? I'm using this formula. Let me just go up real quick here. I'm using this formula up here. So it says 360 divided by n. So it's 360 divided by 5, and that is 72. I want you to think about this one. I don't like to just use formulas without understanding, okay? Right here at the center, if you just spun around, that's 360 degrees all around. Okay? And if you just take one slice, like one central angle, you'd have to take 360 and divide it by 5, because technically, watch this, if I were to draw them all, right, you would have 5 central angles. So when you have 5 sides, you have 5 interior, 5 exterior, and also 5 central angles. Okay, so that's where this is coming from. So this is central. Exterior, this is where it's going to go to, you can have choices here. Exterior angle of a 5-sided shape is also 360 divided by 5, which is 72 degrees. Or, what else do we know? We know that exterior angle will be 180 minus the interior angle. Would you, this is from the previous page, right? We know that they're supplementary, so if I wanted to know my exterior angle, I just go 180 minus, what's my interior angle again? It's right next to it, the 108 here. And you still come up with the same answer, 72 degrees. So with the exterior angle, you have choices. You could also have found your interior angle using that property, right? If you knew your exterior angle, you could have just gone 180 minus 72 and get the 108 for the interior angle. So they're always supplementary. They're connected, okay? So I'll just say this, supplementary. And D is going to be the last one. D of 5 is n times n minus 3 divided by 2. And let's just do that next door. That's 5 times 2, 5 times 2 divided by 2. 5 times 2 is 10, divided by 2 is just 5. 5 diagonals that can be drawn. What in the world is that? And I apologize, I used up way too much space. I wanted to give you a visual. I'm going to still try to make that happen here. So let's draw a pentagon real quick. Doesn't have to be pretty. But your diagonals are drawn like this. Pick any point here. So from here to here, that'll be one diagonal, another diagonal. That's all I can do at that point. Then I go to my next corner here, and I try to draw this diagonal. That's 3, 4, and there's one left in this corner. If you go to this corner, this has already been done, but this one is new here. Right? That's the only diagonal left to be drawn that connects the vertex or the vertices, right? So there's 5 diagonals, and so instead of drawing it, we can just calculate it this way. This tells you how many are possible. Because let me tell you, it gets quite crazy as the sides increase. You do not want to draw them to figure out how many there are, because you would run out of highlighters to distinguish them, right? So, but diagonals is rare. I don't use it a whole lot, but it's there nonetheless. Okay. Let me box that in as well. Okay. I want you to try this for a bit. Okay. Do you know how to use these formulas? I hope that one example is enough. So let's go to page 34. And I want you to label ice. Okay, so one interior, one exterior, and one central. And then I want you to calculate the values of all of those angles, psyched, right? Psyched, S-I-C-E-D, for this particular shape, okay? And then we'll continue. Yeah. Just for the sake of time. So if you want to just check your answers real quick, 11 sides, right? So the sum, obviously if you miss the sides, then everything is going to be off, but try to fix that if you can. So this is the sum of all interior angles. So every single interior angle, if you were to add it up, that'd be that. Okay. Did you know that this formula works for a triangle as well? It's always going to be 180, right, for a triangle. You plug in 3 here, right? 3 minus 2 is 1. 1 times 180 is 180. Right? So it works. We don't tend to do that because we just memorize that, right? But here are the values. Interior angle, they're a decimal, right? So that's not a whole number. And then my central angle my exterior angles, which can be done in 2 ways, and the diagonals, there'll be 44 diagonals. Maybe that's a bonus question right there. Draw all the diagonals by hand. Right? No, not really. So for this one here, I would like to take the time to just quickly have that in your notes, right? And so you should identify, right? Right, angle A would simply be, you count the number of sides. So that's the thing about polygons, there are no angles given. You can figure that out just by counting the number of sides. So when you count the sides, you should count 15, right? 15 sides. So I know this is one interior angle, so I go 15 minus 2 times 180 over 15. Okay, so that would be 13 times 180 over 15, which ends up being 156 degrees. So the more sides you have, the bigger these angles get, because if you were to go to infinity, it would be a circle, right? So the angle is getting bigger and bigger and bigger. The more sides you have, the bigger the interior angle gets. Okay, keep that in mind. C is not the central. I'll just say this interior angle, right? C is not a central angle. It's what? It's the exterior. So I didn't put it next to this one, right? You could have just said C is 180 minus 156 if you wanted to, and that is 24, right? There you go, and that's just an exterior angle, and I know that, right, these are supplementary, so technically you could have brought it here, or you can say this. Let's go to the bottom here and just extend it and say, hey, this is 24 and this is 156. Right? You're just putting them together there. B is not a central angle. You got to be careful with that one, because a central angle only has one of the sides in between it. Okay, so technically this is a central angle, right? And central here. I don't want to use C because I already have it here. So there's a central. So B is really two central angles combined. So if there had been 3 sides, right, spanning that angle that you see that's coming from the middle, then it's just 3 central angles. So I will just say this, central angle would be 360 divided by 15. Okay, and that is 24 degrees. A central angle is 24. Angle B is 2 times 24, which is 48 degrees. Okay, that angle right there, that's the whole thing here. Okay, the whole thing there is 48 degrees. It's 2 central angles there. Should I give you a warning there when you look through your notes down the road? Careful. B is not a central angle. B is not a central angle. So watch out. The homework questions are going to have some of these, so you just got to watch out for that later on. Fun stuff, eh? You never know. You never know. You might get a polygon in your life at some point. Right? You know what to do. This table, I used to take class time to fill that out, but I think it's honestly, you're gonna fall asleep. Me just going through this. What is this table? I would like you to know the prefixes that go along with the names of the following polygons. So what I'm going to tell you is I'm going to give you the prefixes, and then the rest I will ask you to fill in for homework. Okay? So here it is. We have our tri, right? So I will just do this here. This would be the prefix is triangle, 3 sides, right? Quadrilaterals, 4 sides. Penta, 5. Hexa, 6. Hepta, 7. Octa, 8. Nona, 9. Deca, 10. Deca, decade, right? And then there's nothing for 11. I don't know what happened at the meeting where they decided the names, but dodeca is 12. I would expect you to know the names of these. Anything past 12 sides, we call it by the number of sides. So a 14-sided polygon or a 20-sided polygon or whatever. Okay. And so if you want to, I will make this very optional. So if you want to find a sum of all interior angles for each shape, and then the interior angles, and then the exterior, and then the central, you go for it. And I'll show you what it looks like when you're all done. So I hope you're, even if I cover it with this, you'll still see it, right? So this is what it looks filled in. I think the biggest part of this is to see that the interior and the exterior angles are always supplementary, right? 90 and 90 for a quadrilateral, that's 180. Pentagon, we did that earlier, right? They add up to 180. Hexagon, right? So your interior and the exterior angle, even if you use the formulas individually, you still see that they're supplementary, right? So it's up to you. I'm not going to make you fill this in. I thought there was a time that I would use class time, but especially now with the interruptions coming up, I will not do that. Okay. 36. Let's go to 36. We're going to use these formulas to, there's always a little bit of algebra everywhere we go, right? So working backwards, I call this, working backwards. You're going to isolate for the unknown. Basically, watch this. Finding number of sides. That's really what you're going to be doing here. And you can't guess and check, right? Some students just try plugging in values, say, oh yeah, n is this. I need to see the work here. That's the point. Right? Sometimes you'll be given one of the formulas we've just talked about. You're psyched about this, right? I tried. I know it doesn't work. Start with the appropriate formula, then isolate for n. Okay, important here. Start with the appropriate formula that goes with what you're supposed to do. What are we talking about? Central, interior, exterior. Which formula are we talking about? Start with that, plug in what you know, and then work backwards. Okay? So here, the sum of interior angles of a polygon is this. Figure out the number of sides. This is as basic as these get. Okay, this question right here. So we know this one. We know that the sum of interior angles would be n minus 2 times 180. We know that this is S, right? This is capital S. This is the sum right here. So you substitute that in for S. And then we're going to work backwards. So I'm going to use a red pen there. 3060 is equal to n minus 2 times 180. And let the fun begin. Okay. So you want to slowly take stuff away around n. Okay. So some students would distribute this. That's their first go-to. And there's nothing wrong with it, but I think it complicates things. What I would do instead is just to see, hey, the 180 is multiplying this whole bracket. So we are actually able to just say divide by 180, divide by 180. And I can't go through all of the examples with the time we have, but same idea every time. So this gets you to 1, right? 180 divided by 180 is just 1. That's why we cancel it out. It's no longer relevant. And then on this side is where the actual calculations happen. Okay, I don't have the key in front of me right now, so I'm going to do this with you. So 3060 divided by 180. Hey, that's exactly 17. Perfect. Because we're dealing with number of sides, if you get a decimal, go back, check. You probably made a mistake, right? Because number of sides should be a whole number. Why is the bracket gone now? Because I got rid of the 180. So I just, right, I divide this, get 17, no more brackets. And now, what's going to happen to the -2? It's going to come over adding, okay? So we have 17 plus 2 is equal to n. So I can say that 19 is equal to n. So that polygon we're interested in, we know now has 19 sides. Okay, polygon has 19 sides. Bingo. Okay. We're doing good time-wise. Can I ask you to do B on your own? B is not bad at all. Sorry, I shouldn't say that. If you are stuck today, that's fine, but just try it anyways, right? So B on page 36, give that a try, just so you stay awake, right? You stay with me, and I'll do C because C is a little trickier. You will see why in a bit. Aha. All right. Oh, we're freezing. Unfreezing them. Polygon, right, has exterior angles of that. So we need to start with this formula, which we know is 360 divided by n. So we plug that in, right? That's E right here. So that's 11.25 degrees. Oops. Is equal to 360 over n. And so here's the power of 1. I don't know if I've done that before, but right, you just say, hey, that's 11.25 over 1. And you should see cross multiply and divide like a proportion there. So it's 360 times 1 divided by 11.25. N is equal to? What is n equal to? I actually don't have that in my key. Anyone? 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 32. 32 sides. So this one is actually probably even easier than the one we did up here, except for, right, sometimes it throws us off that there's just a number and then we have a fraction on the other side. Remember, right, you can turn any number into a fraction by just putting a 1 in, underneath it, and you're good to go. One more. This one is, I'm going to show you two methods of doing this one. You choose which method is more convenient. I will not make you choose one over the other. But let's do this one together. A regular polygon has interior angles of 171. Okay, what are the number? Calculate the number of sides algebraically. There are two methods. So let's do method number 1. This one is probably a bit tougher, but I know I need to use this formula. I is equal to n minus 2 times 180 divided by n. Yikes, right? So the 171, this is I. I already know what it is. I'm not calculating it. So you put that in 171 is equal to n minus 2 times 180 over n. And what you need to do here is multiply both sides by n. You want to get rid of this, okay? So I basically say, okay, I take this whole side, multiply that by n, and I do the same thing on the other side. Okay? That effectively gets rid of this. And on this side, you're left with 171n. On the other side, I'm going to write this, I'm going to copy that line so you're not. And at this point, it is, if you go back to the very first question we did on this page, we're back to something similar here, but I would not divide by 180 here. I would not divide both sides by 180. And why not, Mr. Dixon? Because here you have an n. So if you go 180 divided by 171, you're not just going to get a number. It's going to be something n. You could go that route, but I will not. So in this case, I actually do distribute. So I distribute this out like that. So I go 171n, and that gives you 180n minus 360. I'm going to zoom into that one because it's probably a bit smaller. There. And you can now collect like terms. I don't know if you see, like that's basically the reason why I distribute here, because I know I'm going to get a number tacked on with n. So I'm going to combine these. I'm going to bring this one over to the other side. So 171n minus 180n, sorry, yeah, minus, that's good, is equal to negative 360. So you're left with negative 360 on the other side. And you get a negative here, right? Whether you see it or you use your calculators, that would be negative 9n is equal to negative 360. And because of the negative on the other side, it's always going to work out still. Okay, so I'm going to divide both sides by negative 9, because the double negative here will turn into a positive value. So this goes. So n is really 40. It's a lot more work, right? I would practice that. I'm going to give you a bunch, like at least one, if not two of these in the homework. So I would practice that. This is your second method, which I prefer. I think it's easier. Okay. So I'm going to leave that here for some of you that are still copying. But method 2 is done as follows. What if we knew, what do we know about the interior and the exterior angles? They are supplementary, right? Remember that I told you that earlier? They're supplementary. So I'm going to say, hey, that means that the exterior angle for this polygon would be 180 minus 171, wouldn't it? So the exterior angle would be 9 degrees. Important. So I'm flipping this question. I'm like, nah, I don't care about the interior angle. I want to look at the exterior angle, which is 9. Okay, that's the exterior angle. So what do we know about the exterior angle formula? It's a lot easier, isn't it? It's just this. So this is where knowing properties is going to help you, right? It's going to make it a lot easier. So this 9 goes in there. Okay, I'm going to use red. 9 is equal to 360 over n. And the magic of 1. So you go 360 times 1 divided by 9. Isn't it going to be the same? Watch on this side. What did we end up doing? 360 divided by 9, right? They were both negatives, but it still ended up being the same. So 360 times 1 divided by 9. And that is 40 sides. So regardless of how you do it, remember, everything is connected, right? So just a different approach. One looked at the interior angles and just stuck with it. The other one is find the exterior angle and then use exterior angle to solve for the number of sides. Which one is your favorite? You pick. Just be careful with this side that you show me enough work. You don't just skip. But you definitely will not be getting marks on a question like this if you just guess. You can guess to see if you're doing it right, but that's that. So, what's your homework? I'm going to ask you to do okay, I'm going to give you a bit of a buffet here. 37 to 41. That's a lot. I know. So homework, 37 to 41. There's a big chance that I post this in chunks, not all in one shot, because it's two different worksheets combined. You pick what you need to pick in order to feel confident, right? I will post the key. We'll stop here. And the triangle piece, I might just fit that in tomorrow.